Hello, this is quick little video. What we're going to be looking at today is scale factor. So the Pythagorean theorem and the similar triangles is on a different video. I just want to make this super crystal clear. This is something that you'll use more than almost anything that we use in math. This is a really practical real life application. So when we're using scale factor, you have to remember this. No, say it in any accent, however dramatic you want to be. So no, the big thing here is that we're looking at the new shape divided by the original. This is going to give us something called the scale factor. So right here we got little Jimmy. Why Jimmy? I don't know. Little Jimmy is 2 centimeters. Now, Jimmy likes to play on the photocopier. So what does he do? He goes in and he smashes his face up on the photocopier like this, squishes it in, and he enlarges it to here. Okay. Now, his new face on the printed page is 4 centimeters. It's an exact replica. An exact well, close enough. It's a replica of his face, but now it's 4 centimeters. Now, I know you can look at that and go, well, this one was 2 centimeters, and this one was 4 centimeters. So he scaled up by how much? You see? Not so easy. So we take the new over the original. Now, what was the new one? Was it his face or the photocopy? It's the photocopy. So we take the new, which is 4, we divide it by the original, which is 2. 4 divided by 2 is going to give us 2. First thing, what you need to remember is that if we have a scale factor that's bigger than 1, if it's bigger than 1, it is getting larger. If I scale Jimmy up by 2, he gets bigger. Now, if this is my original, let's say this is Jimmy's original face, and he is going to go to the photocopier, squish his face on it again, and he's going to end up with this. Let's do this one in brown. So now my original, the new is 2, the original is 4. Well, 2 divided by 4 is just 1/2. Lucky number 2, this is a reduction. So if it's bigger than 1, that means we've made it bigger. It makes sense. If we multiply something by 4, it's getting bigger. If we multiply something by 1/2, that's like dividing, right? If we divide by 2, it gets smaller. Okay, so always new over original. Now, when we're dealing with the tree project, when we're dealing with similar triangles, you get to decide which one is the new and the original, but don't make it complicated. Okay, all you need to do here is think through the project using that. So here we go. I have a problem. I have a rectangle that has 2 dimensions. So this one is going to be my original. This is going to be my new. It's not quite as straightforward as the first example because here I have an unknown. So they're giving me different parameters. So there's 2 ways to set this up. And this is why students struggle with this, okay? There's 1 and there's 2. The cool thing is that however you set it up is right. It doesn't matter how you set it up. So when I just look at this, if I go from 4 to 8, well, I'm multiplying by 2. The scale factor is going to be 2. So for those of you who like to do things in your head, if I go from 4 to 8, what do I have to do with this one? I'd multiply it by 2. So let's set that one up. That's the first one. So I can take the dimensions of my original shape. Okay, so my original shape is 4 over 2. That's going to equal the dimensions of the second one if they're similar. So similar means they have the same angles and they have the same ratio of side. So on my new form, I have 8 over x. So what have we actually set up in this one? This is a ratio between the height and the base. So the height of this shape is 4. The base of my original shape is 2. The height of my new shape is 8. The base is going to be, I don't know. How would I figure this out? I've stressed this a lot this year. If I have one unknown, I cross multiply, and then I divide. 8 times 2 is 16. Divided by 4 is going to give me the answer of 4. Okay, so this way I can compare the shape to the shape. Okay, so that's a fairly common way. It's not my preferred way. I actually like to stick to the new over the original. Okay, so when we set that up, let's do it over here. I'll do this one in brown. So we're going to set it out like this, the new over the original. Now I have to decide what I'm going to compare. So this one here, I know I both have the height. The height of this is 4. The height of my new shape is 8. So I'm going to compare the height between the shapes. So my new one on this side is going to be 8 over 4. Now right away from fractions, I know 8 divided by 4 is 2. So that's right. Okay, I can see that one in this. But now I have to compare the base. So we're setting up these equivalent ratios so we can determine what the scale factor is. So now the base, what's my new base? It's this, it's my unknown. I'm going to go x. The base on my original shape is 2. So there, I've got my ratio set up. I'm looking for x, so I cross multiply and divide. I get the same answer. 8 times 2 is 16. Divided by 4 is 4. X equals 4. Right, now you may have to watch this a few times. So this one here, I love this because I don't have to kind of mess around with what I'm doing. This one here is simpler because I don't have to get too concerned about which is the new and the original. I'm just comparing the ratio between the base and the height to the ratio of the base and the height. It's all equivalent fractions. Let's take a look at this one. This is the one that you're going to need to do your tree project. So in here, how do I know these are equivalent triangles? I have this big triangle on the outside, and then if I split it, the big thing here is that for triangles to be equivalent, they have to share 2 angles. So they both have a 90-degree angle, and they both share this front angle. Oftentimes they'll set these up like this as well. So they'll give you 2 separate triangles, but they'll tell you that this one and this one are both 30 degrees. So if they share an angle, they're equivalent. That means that the ratios between the sides are going to be the same. Let's do this one. I'm going to use the new over the original on this one because that's my preferred way. Let's go to red. Why? Because it's fun. New over original. Now, I always like to start my first ratio with the 2 knowns. We can only solve these when we're missing one variable. So here I know the base of this is 3 and the base of this is 12. So we're going to do the base first. I'm going to compare the bases. Which one should we make the new? Is it a little one that got bigger or a bigger one that got little? Here it doesn't matter. So I'm going to call this the new. The big triangle is going to be the original. So my new measurement is 3. My original measurement is the whole length. Another thing they'll do, be aware, is that they'll put this as 9. So if they tell you that from A to B is 9 and from B to C is 3, you have to add up those 2 numbers to get 12. So this is going to be 12. This is equal to the height, my unknown. Well, which is the height of my new triangle? It's 5. I don't know the height of my original. So what do? Say it out loud. Cross, multiply, multiply, divide. Cross, multiply, divide. Ah, sorry. So I'm going to, that's not right. Is it? Yes. Cross multiply. So I'm going to go 5 times 12, which is 60. Then I'm going to always divide by the third number. So this is going to equal 20. For those of you really quick, how do I get from 3 to 12? I times 4. So I can also just times by 4. Answer is 20. There we go. My scale factor is going to be 4 because that's what I multiplied the side.